All right. Hello, hello. All right, so yesterday we talked about equation of tangent line. Is after we take a derivative, we plug in the x value. If we plug in the x value, we know the slope at that x value, slope of the tangent. Is that okay? That's last yesterday. Okay, so but I do want to talk about there is another line that you have to know is besides equation tangent line. So this is the equation of tangent line. And guess what? If you don't know how to do equation tangent line, you're in big trouble. This is like 10% of the test based on equation tangent line. They can use that for approximation. They can use that for different things. They have other things. So y minus y1 equal to m times x minus x1. Usually, you are giving the x. This usually is giving. And this is the output. And this is slope, which is from derivative. So that is equation tangent line. Now I want to talk about those one more line. Now there is also an equation of normal line. Now you're gonna say, what is normal? Okay. Now normal just a different vocab. You already know what normal line is. It's not just a line, normal. No. It actually means perpendicular. This means perpendicular line. So instead of crossing one point, it's crossing another direction. It forms 90 degree at that particular point. So that's called normal line. So then it's going to be y minus y1 equal to m negative 1 over m times x minus x1. So it's opposite reciprocal. Do you guys remember for SAT? You have to remember it's opposite reciprocal. Now let's just say if I got an equation tangent line slope is 2, what is normal line slope?
Wait, what's that?
If equation tangent line slope is 2, what would be the normal line slope? Negative 1 over 2, just opposite reciprocal. So put 2 and negative, and it's 1 over negative 2. Yeah, opposite reciprocal. So it's called opposite reciprocal slope. In the SAT, you're gonna see opposite reciprocal as well. So like I said, this class does help you on a lot of SAT ideas. This is one of them. So I want to mention about that. Okay. So today's homework, I might ask you equation of the normal line. Right? So you had to be able to do that. Now, with that being said, I want to talk about, yesterday we mainly used this definition of derivative. I want to is f prime of x is equal to limits h approach 0 f of x plus h minus f of x over h. Today I'm going to give you the rest of the even problem that we did yesterday from 33, 35, 37. Today you are doing 34, 36, and 38. 38 is probably going to be the hardest one. And that's the definition of derivative. This tells you slope at any x, any value of x. So it's an expression. It's going to give you a slope at any value of x, right? So if x equal to 2, just plug in, just say your derivative is 2x. If derivative is 2x, just plug in 1, you get 2. That means when x equal to 1, your slope is going to be 2. If 2, it's going to be 4, something like that. Now, today we're going to study something that is more different. So this is a definition of alternative derivative. What do you mean by alternative? Well, this one looks like this. F prime of c equal to limits, instead of h approach 0, it's going to be x approach c of f of x minus f of c over x minus c. Now, this one is a new one. If it's a new one, then you say, okay, what is the difference between this one and prior one? So this one is a slope at not any x, at a particular x value. So like say x value of c. So c could be 2, at x equal to 2, x equal to 4, x equal to 5. I can find out the slope at this point if I apply this equation. So it does not give you a general expression, it gives you a evaluation. For example, your slope is going to be 3, it's going to tell you it's 3. The slope is going to be 5, it's going to tell you 5. As opposed to this one, usually it's going to give you something like 2x squared. Then you can say it's plug in x equal to 1, that's going to give you 2, x equal to 2, that's going to give you 8. So this one give you some type of expressions, right? And this one just usually give you evaluation. Evaluation is some type of number. So that's what it's going to become. So we're going to show you how the definition of derivative works. Now, to just kind of give you a heads up. Oh, by the way, this is something pretty cool. You can scroll on the side and you can go all the way down. You're going to show you something calculus secant line. And you can calculate a slope at this point here, 0.709, by shrinking this point from h of, as I said, for example, this h is roughly 2.5 right here. Shrink down, eventually your slope is also going to changing, your slope changing, your slope changing, 0.719, until you get to intersect almost close to intersect to each other. So that you got roughly the slope of 1.039 something. Right? If I really get it down to 0, then you're gonna find out that it's gonna be does not exist because x pineapple equal to 0. But you can get close to it, and that's the definition of derivative. Now it turns out if I dot a slide, then you can see this thing going on. It just kind of keep, you know, you can find tangent line at every given point. If I stop it at any point, that's my, you know, that's going to be my tangent, which is this slope is going to be negative 0.04499, and you can stop at any point. So it gives you a general expression. Now, as opposed to this one, is a little bit different. So as opposed to I have a function. And this function has something like, I don't know, something like this. Okay, so we have a point A and point, but now we're not going to have point A. We're going to have point C and a point X, right? And point C and point X are going to give you output. This is the output. What will be the coordinate of the first output? What will be the coordinate of the first point? if this whole thing is f of x. F of c, no, that's not coordinate. Coordinates x and y. C comma f of c. And this point is going to be what? X comma f of x, right? Now what happened is between those two lines, I'm going to draw a slope. This is the slope of secant. And so that was secant between 2 points. Now how do I find the slope of the secant? M secant is equal to y2 minus y1 over x2 minus x1, right? Now it's equal to f of x minus f of c over x minus c. Now I'm going to say, well, here's m of tangent. M of tangent basically the same thing. We just reduce that x going towards c. So we take this and we move that point towards c. Towards c. So if I'm going towards c, guess what? My next point is going to be here. It's like this, right? And my next point is going to be like this. And eventually I'm going to get a slope of tangent, which is going to be like this. So eventually I'm going to get a slope of tangent like this. Like this. So when from green line, if I close my distance from x to c, then eventually I'm going to change to a red line. Yes.
If that's the tangent line, does that mean that there's a secant line that equals the tangent line?
No. Oh, I see what you're saying. In this graph, because it is up and down, what I mean intersect one point is that region, just this region from this point to this point. It's from that small x range, not after that. You know, that line could intersect to go back to the graph, but that doesn't mean, yes, in this particular case, that particular tangent can equal to some other secant. But it's not what we look at. We only look at that region. In this small region is that tangent to this graph. We're not looking at outside there. So m of tangent is going to be, this new function is equal to limits x go into c, which is like this, of f of x minus f of c over x minus c. So that becomes a new way to find derivative, but directly give you evaluation. Directly, without any hassle. Are we okay? It's after lunch. Are we okay here so far? Okay. Now what we're gonna do is we're gonna practice a question. And the question I'm gonna give it to you is a little bit harder. So this one requires a little bit different. So plus 6x, and let's just see if you know how to use this definition, alternative derivative. So let's just say if we want to find out a derivative at x equal to 2, can we use the alternative way to find it? The alternative way is not too bad. We're going to say f prime of 2. Does that make sense? Because we want to plug in 2. That means its limit x approach to what? 2. Of f of x, which is x cubed plus 6x, and then plug in 2, f of 2 in this case is what? 20. So it's going to be minus 20 over x minus 2. What happens if you plug in 2? Zero over 0, you're right. If it's 0 over 0 means what? Huh?
Do math.
Do math. Okay, what kind of math can I do here?
You can do like the long division.
There we go, long division. So math could be any kind of math in algebra. And Joe's like, yeah, we can do long division. Or we can do synthetic division too. Remember, long division and synthetic division is a way to factor anything with higher degree than a square. So if anything to the third power, fourth power, you can actually use synthetic division and remainder theorem and factor theorem to factor something. This one is a little bit easier. So let's talk about how to do long division though. Do you guys know the simple fact that I didn't know I was watching this YouTube video and I saw this infomercial come up. And it was like, it's a math teacher talk about how to teach math. And I usually don't like those people because I think I'm better. But this guy was interesting. He's like, do you know this long division sign means what? Right? Do you know what this long division sign, right? And not just say if I have 8 divided by 2. Do you know what does that mean, right? Do you know what is that notation of a straight line there? What does that mean? And I was like, I don't know. And the guy was like he's like he never knew it for the longest time. He teach you math for 30 years, but he didn't know what it is until one day he went to training and they told him what that meant, and he was like, "Oh, that makes so much sense." Do you know what that meant? Amil?
Maybe like an area thing, like side by side.
You're right. It's area. Do you see it? What do you see? Yep. The area is 8. If I have the height is 2, what is my width? Which is 4. It's pretty cool, I don't. Like, very, very smart guy. 2 times 4 equal to 8, or 8 divided by 2 is equal to 4, which is finding on the other side, right? Pretty interesting. Start with long division. Did all you guys know how to do long division? Like, if I have 1972 divided by 12, but I remember one year, right? I have this kid named Yasin. Still remember his name. I was like, yeah, can you do long division? 1972 divided by 12. I said, Mr. Yi, I got you, right? He go up the board, he go like this. And he's like, wait, I don't know how to do this. Shit. And so yeah, no, please don't do that. It's 1972 divided by 12. And I will say it's like, if you don't know, you actually don't start at the first spaces, because technically you're only looking at the 1. 1 cannot go into 12. So you actually have to go to the second space right here to start with 1. And that's 12. And that's, I don't know, 77. And the 6. What is the subtracting sign? 77, 72. And then subtracting sign, that's going to be 52. And then 4 to get to 48. And this is 4, right? Now, correct way to write this, not 164R4, is actually 164 plus 4 over 12. That's the correct way to write it. That's what is the right answer. This is such a third grade, like they just taught on fourth grade when you learn about division. It's R4, but it's not. It's actually plus 4/12. So you should get 164 plus 1/3. And that's the correct answer. By the way, you can actually do some long division here. So it'd be x cubed plus 6x. The problem is that you cannot do plus 6x. What do I need here? 0x squared plus 6x minus 20, right? So then you can do long division now, which is x minus 2. You are not going to start right here. Don't start right here. You're going to start right here because you want to have two terms. So it's x squared. So it'll be x to the third minus 2x squared. Again, this is a minus sign. It's kind of important. So that's what makes this one 2x squared. Does everybody see that? Why is that 2x squared? It's minus negative, right? Yes, I'll come back to me. And I'm gonna plus 2x. Why 2x? Because I try to get rid of 2x squared. 2x squared minus 4x. Yes, what am I gonna get here? Nope. 6x. Nope.
Positive 14.
Nope. $10x. 6x minus negative 4x. 10x.
That was 8. Not 14.
Oh. Oh, I guess you'll never get it right then. Minus 4x, right? So I'm gonna plus 10 here, and that's gonna be 10x minus 20. That's equal to 0. So that's equal to limits x approach to 2 of x squared plus 2x and plus 10. That's equal to 18. And the answer is 18 in this particular case. It turns out 0 over 0, you got one more thing you had to learn is this, you might be able to do long division if something is that sort. But yeah, do you guys know how to do synthetic division? I'll show you. Remember the first worksheet, I told you algebra skill, every algebra skill you're gonna need it, yes. 18 means when limit x approach to 2 is 18, which is f prime of 2. That means when x equal to 2, my slope is going to be 18. My slope is going to be 18.
What does that have to do with the C?
C is when x equal to 2. My slope is 18. You sound like you're lost. Okay. What happened when x equal to 2? What's my y value? I think it's 20, right? So check it out. X. What was the equation? X what? X cubed plus xx? Yeah, we know at we're gonna go to 2. See, the slope is going toward 18. Oops. Because this is not 2. It's 2. It's going to 18.06. So that means this particular slope here at this point is 18.
It's the same thing as finding the derivative and then plugging it in.
A slightly different. This one give you evaluation because the other one's going to give you 3x squared plus 6 and you plug in 2. This one just give you 18. No, this one just give you evaluation as opposed to give you a general expression that represent all slope. This one just give you a slope at that particular c. Does that make sense? Madeline, you're gonna pick a number. Can you pick a number? If it's a bad number, it's your fault. Pick a number. No, that's too easy. Okay, 4. 4 is fine. 4x squared. Pick a number between 1 to between 5 to 10. That's 9. 7. Okay. All right. And we're gonna say I want to find the slope at I'm gonna pick a number, let's say 2. Can you find a derivative? Use alternative derivative. Using definition alternative derivative. Very loud. You guys finish? Yeah, see yourself fall asleep.
I heard you say. So I'll leave it on my mind. Hear me say, yeah, my dreams.
Wake up yourself.
When I woke up, I was like, 8. The next day, I said 8. All right, positive 14. He was like, no. I was like, what? Thing.
You guys got the same answer? Okay. Okay, so now with that being said, you guys hopefully you guys all get same answer. This one doesn't need a long division, but your homework question is gonna have a question that need a long division. And so we're gonna talk about how much time I have? 6 minutes? Is it? Great. Okay, so this is the one thing I want to talk about is this last card is called limits exist, and it will be limits x approach to a from the left of f of x equal to limit x approach to a from the right of f of x. Okay, so this last part is continuous, which is we have learned before. Continuous has 3 requirements, which is f of a is defined, b is limit x approach to a of f of x exists, which is the prior thing, c, which is limit x approach to a of f of x is equal to f of a. Now the last one is called differentiable. Now this is the last stage. The last stage is basically, I'm going to write out here, which is limits x approach to a from the left. But it's not f of x, it's actually f prime of x is equal to limits x approach to a from the positive side of f prime of x. So this is slope from the right or left equal to slope from the right. If that's true, then it's a differentiable. Now, one thing is I write down into this pyramid is to tell you, if some function is differentiable, it automatically imply it's continuous and imply the limit does exist at x approach a. If I only told you continuous, does that mean it's differentiable? No, because continuous is on the bottom of the pyramid. It doesn't mean that you are differentiable. If I just told you limit exists, does that mean it's continuous or differentiable? No. So it has a hierarchy. The highest things have all the bottom things. So I draw as a pyramid scheme. Now I'm going to tell you when function is not differentiable. It's not differentiable. You have to understand this, today's homework. When it's not differentiable, 1, the endpoints. 2, vertical tangent. What is a vertical? Endpoint is like this. It's like square root of x. This endpoint, that's not differentiable. Vertical tangent is like this. So I don't know if you guys take, anybody ever take chemistry? You take it last year? Who take it last year? Okay, so it's like a titration curve. It's like this. So this point is not differentiable. It's a vertical tangent. Third thing, vertical tangent. Third thing is called sharp turn. when it's a sharp turn or a cusp, it's not differentiable. So you have to know endpoint is not differentiable, vertical tangent is not differentiable, a sharp turn is not differentiable, or a cusp. Cusp is like y equal to x to the even over odd power, 2 over third power. A sharp turn is like absolute value x. Those are the example of that.
What is
Last one I would like to mention is a vertical asymptote. That's also not differentiable, vertical asymptote. So when you see a sharp turn at an x value, it's not differentiable. When you see a vertical asymptote, it's not differentiable at vertical asymptote. When you see a endpoint, that's not differentiable at the endpoint.
top of the pyramid was slope limit equals slope?
What?
Top of the pyramid, slope limit equals slope.
Is slope from the left equal to slope on the right?
Right.
That's why it's an f prime vec.
Scroll down, scroll down.
My phone died, so I can't send it on. I have it.
You actually can.
First, it's easy. Second, third,
Yeah.
fourth, fifth. Yeah. Put 100.
You and Will get nothing done. Yeah, that's because Will's not here. You didn't do that in class.
I did it 5 minutes on.
You. Bye. Bye bye. Bye. Goodbye. Oh, I'll see you this afternoon, right?
Yeah.
So you say Matthew is coming?
I think Matthew, Matthew, Bryce, Ty, and then whoever, I think Xavier you said also.
Okay.
Okay.
What's up, Sophia?
No one's here. That's kind of brainy. There's at least one person in your class.
What?
There's always at least one person here. I'm gonna go to the bathroom.
What's
Tony, did you do homework?
That's good.
You understand it?
Yeah, the page is on the back. And that.
Brandon, did you do homework?
Yes.
Dude, 1 minute remaining and close flat.
All right.
So yeah, I have a yeah,
It's gonna be good.
it will be good.
All right. That's what
All right. Any homework questions? We both not here the second days. Anybody know what I'm doing?
He's from the
Minus one equals 2 times x minus 1.
Oh, he's not coming because it does game today. Martian Ben is gonna be day-to-day.
That's an hour. What?
He does stay in there.
Yeah. Oh, I have a flow back. It could be a lot.
I'm gonna be about
39.
Oh,
yeah,
Ben.
Oh wait, me too. Why did I say 0? I think I got another question. Yeah, I got one on x plus my x minus. Yes.
like you.
So they call it, I don't know what they call it, it's a lot of type of problem. They have an integral too, integral of x to the x to the x to the x. There's a lot of time. That's actually how to choose competition.
Yeah, I want to try this.
All right, no questions for homework or there's a question for homework?
It's really interesting.
I just squared it here, you know?
No, it's not about it.
Yeah, what's the definition of that? Just
If you assume that's equal to x, okay, that's what we talk about.
no more. All that equals x. And you know what it is? I'm in a level.
I mean, it's hard calculated.
Yeah.
All right, so any questions on homework? No? Too easy? Sam, very good job. I've seen a lot of improvement. What? how to do 37. Can somebody teach Tony how to do 37?
I'll teach you.
Hey, Nicholas, Nicholas can learn how to do. You can use any board. Any other question besides 37? Newman, do you have any questions?
No.
No? Okay. Mason? No? Ilya?
No.
Brendan?
No.
Brendan, did you do your homework today? You're supposed to use definition to find all the things. You did not set the definition. You gotta learn how to use it. Go out before learn it. You're gonna have a quiz sometime next week. I'm thinking about Monday and Tuesday. I don't know which day is it, but it's gonna be about this stuff and horizontal asymptotes.
Should do Tuesday.
Should do Tuesday?
Oh yeah, but Tuesday. Alright, what is it? What's the line? Line?
How long did you play basketball? How long have you been basketball? When I was in like high school,
That's what I did.
but then I didn't play for a long time.
This is really weird. What's the shape? Is the answer greater than six? What is it approach? I can't really. Is it? Because I'm never reached six. The person is for the never reaching for. What? No, I'm not gonna say that. Really no person. That is the law. Very simple number.
Practice your algebra skill. Today you're gonna have some more.
Like split it up. 6 equals 3 times 3. And 2 wasn't the hand. You're that? Yeah. I don't know. What is-
Don't show him. Don't show him.
Yeah.
He'll figure out. I mean, it's hard to figure out on your own, but I mean, don't show him.
From the homework?
I'll get the answer to you in like less than a year.
Less than you. No. So math computation questions are not like difficult. You just have to create new perspective.
Yep.
You just have to create new perspective because it's all about perspective. You're gonna realize that pretty soon. You just look at things a little bit different. If you look at it a little bit different, you're gonna do it okay.
Yeah. Have you done the 0.9999 repeating wherever equals 1? Like the proof for that?
Yeah.
Do we make another one?
Danny, I think you will enjoy math competition as well. So stay after school today. Then you can start with today's homework. Question 56.
Okay.
That's a challenge question. And it's enough for everybody. Nobody had to do it. Only do it for fun.
This H keeps in reality, right? So it's a fraction over a fraction. Yeah. So it's, think of this as 1 over 2 over 2. 1 over 2 times 1 over 2. Right? You can also think of it.
Brandon, if you don't know how to do it, go up on the board. Brandon,
Yeah.
if you don't know how to do it, go up on the board and figure out how they do it. You gotta be able to do, according to what I see, you don't know how to use definition derivative.
It's negative H. Yeah, so the square root of 6 plus is actually all that equals, yeah, but this, so if you do like, that, one thing like,
You don't know how to do it yet. Yeah.
where is square root 6? Isn't that that way? You should solve for it, right? It's the same thing here, right? Yet something different, just it's one first.
I'm on what the question in theory. Why do you like in the notes? Why are you able to plug in this into X plus H?
Why?
Yeah, just like
It just because that was a definition derivative. I show you how this come in play before, and basically just 2 points. You start with the secant line. This is actually the slope formula. It's y2 minus y1 over x2 minus x1 in terms of 2 coordinates. It starts with secant. It's h gonna go towards 0, so it's gonna changing from a secant line to a tangent line.
oh yeah, I remember.
And that's why there's x plus h here.
Okay.
And it's not because of anything else. Just you can plug in anything. That's just the way it is. You can plug in x plus 2. You can plug in x plus 3.
And it would be the same.
It'll be different. It will be everything is going to be different, but depends on what the situation is. So if you plug in x plus 2 into the equation, for example, if I have today, I have let's say let's just say if I have f of x equal to x squared, right? You can plug in x plus 2 into x if I wanted to, right? So f of x plus 2. It basically just pay attention. It just move the graph to the left.
Yeah.
You can plug in anything you want. You can plug in 5. You can plug in 6. You can plug in x plus 2. You can plug in, absolute value x. You can plug in x minus 5. It's moving right 5.
I see.
What's up?
So, you know how you multiply this by this? Would the negative one become positive or stay negative?
This one negative. This one's negative 1.
Still.
Yeah, because of this times this, it's gonna be negative parenthesis x minus 1. Oh, this one's possible.
Sounds possible.
So because there's a parenthesis right here.
Basically, it's like. Basically, it becomes x. Root x.
Matthew, what happened to Reebok? He haven't shown up for 2 days. But he did try to like attend the stream yesterday, so I was kind of proud of him for that. Nicholas, do you know what happened to Reebok? Huh? No, I know he just didn't come to school, but it's like he's sick or COVID or whatever.
Yeah. Oh, wait, oh, I know. Plug in, so the ports are plug in 0 on this side.
Danny, you figure out yet?
They're halfway there. Halfway. It becomes. That just be a chunk. Right, plus which is 2x. Right. I'm good at yeah. This thing is in this step alone, you multiply this makes sense. We plug in 0 on 3, right? So you plug in 0, and we have root x on root x, which is. Well, you have root x. That's x.
Oh yeah, there's negative.
No, just go into the parentheses. Yeah. Root x plus root x is 2x. So that's in your root x. Then you have to set that equal to this. Yeah, you got that.
I haven't solved it yet, but
This equation to this equation.
are these points on decimals? Okay. Okay.
How would you solve it?
No. This is how I teach higher level kid. Just keep my mouth shut. Because you might find a better way than I do, right? I did say do it at your own risk.
Oh, no. Hold on. Okay. You have to get rid of this.
Oh yeah, I find it slow from that.
How do you get rid of this? How do you get rid of this?
Wait, I find it slow.
One second, let me do this.
Got it wrong?
Huh? No, I'm walking through it. That one. So, how would you do it? What would you do? You get rid of this 2, right? 2 on the right, right?
Then,
Multiply both sides by 2. This cancels out. Get 2 over x. Right?
cancels,
And then.
and then x. And then. That's slow.
Is this square root of x plus square root of x? Square root of x.
X times root x. And that was x.
That's zero.
Yeah, but
What is
the
it?
problem
Yeah.
Oh, okay.
makes sense because like
Wrong.
the 2 is already multiplied.
I thought it was
So you just
really-
combine 2x and x. So 2 cancels.
Yeah. That's the one they gave me. One negative 2. Okay.
X.
So this is 1. This is just the intersection. This is
Any help off that?
No, I'm just saying. I'm just seeing it.
2 comma 9. And this is negative 1. 1.
My thing was very 2 minus 2x.
And then there's plus the
I can help you.
No, it's okay.
Okay, so that's 8 over 3.
Some viewers want to try it.
So just x through x plus
Yeah. What? Slope.
No, that's
From
not.
these two.
Okay, so that's good. I'll take it over here.
No, I don't know.
You're doing good. You're doing good here. Now I'll show you how to show other people. Okay, so it'll be negative 1 over 2x square root of x equal to negative half, right? So what you can do is you can both take out negative
I'm finding it.
and then you can just cross multiply. So
Oh.
2
Depends on who you're comparing.
and then divided by 2 on both sides. So that's equal to y x.
What is it?
Now this part even is
Okay, I have these.
I divide by x.
you can divide by x. What you can do is x to 1 times x to 1. So that's equal to x to 3 over 2 is equal to 1. And in order for you to get rid of 3 over 2,
Right.
you have to do 2 over 3 on both sides.
Yeah, but it's not, and not, they're not.
Because
Oh,
this will become 1.
equals.
And
That's the
Four.
then you go plug in 1 into the original function, so y minus 1 equal to,
Wait,
what is the negative 1 minus 1?
It's still 1. Wait, why can't you divide by x here?
You can divide by x, it's not gonna help you because
I got the
1 over x,
Yeah.
square over x, right?
Yeah, and then you square both
That
sides.
might be
I'll square both sides, okay?
Yeah, and then 1 over x squared equals x, and then you multiply
Oh,
by
x
one.
cubed.
Yeah, x cubed plus 1, and then x.
Okay,
I did that. I didn't do that. Take it off the light bulb. Right? Make sense, Jody? I don't know. It's kind of long. You feel like it's very simple. If you didn't look at the lot, it's very simple. Yeah. Common denominator and so plug. Here's what I have so far. Common denominator, conjugate,
Thanks.
like cross out and cancel. Multiply by the 1 over h.
I'm gonna start teaching today's lesson.
It's basically what we've been doing all the time.
All right, everybody have a seat. I'm gonna talk about today's lesson really quickly. If you don't understand,
Negative 2 times x plus 1.
He said he had a sore throat and a headache, and then he sent me this picture of his feet. Mr. Bob,
that's gross.
that is gross, isn't it?
The weirdo. All right, so Safia, did you got an answer? Is that right?
Perhaps.
Perhaps.
We'll see.
All right, so equation tangent line. Usually equation tangent line, this part is always giving, always. The x is always given to you, and that's the case that on the extra credit, not extra credit, but extra fun question that no one had to do it. So this usually giving, then you can always plug this into original function to get the output. So you get this. And the m is the derivative, which is the slope. Usually it's a value, okay? Usually it's a value. Now you gotta understand that's slope from the derivative. Now, later you might get asked, what is the equation normal line? Normal line means perpendicular line. It's another word for perpendicular. So therefore, if you have equation of normal line, it's going to be opposite reciprocal. You take the m, and it's going to be negative 1 over m. You need to know that for SAT. Instead of, it's just opposite reciprocal slope. If you got 3 over 4 as your normal, your original slope of tangent line, then just negative 4/3.
You put on.
Oh, my bad. It's gonna be 4/3. So that is that. So give me a second. do QuickTime. What's QuickTime?